We are going to start by a presentation from Tony, who is going to present, make a general presentation on the Internet of Things, and then we will follow by a presentation by Mark, and then by Mohannad. We are hoping to finish the presentations in 45 minutes, and then have, let's say 30 minutes of Q&A. Okay, so in order not to be really very late. So let's start with Tony.
Thank you for coming. I will give a small presentation about the Internet of Things. I will try to be as brief as possible and not to get into the technical details, so everyone can get a better idea about this new technology, new model, and a new, let's say, trend. Thank you, Gabi, by the way. So, a small survey in the market, which was done in Europe, about how can you imagine your life. I cannot imagine my life, and these are the statistics. Without a mobile phone, respondents said 97% said yes. Without the internet, 84%. Without a car, 64%. And unfortunately, without the partner, 43% only people. So these are the results. So as you can see, guys, even the laptop and all the rest goes under 1%. So definitely each respondent had multiple choices, and they selected. So today, without the phone and without the internet, are the most important things that are becoming in everyone's life. So this is just the beginning. So Internet of Things, it's the use of sensors in everything, in every object, in every machine, to facilitate the communication between these objects and other data centers, in order to communicate the data and then analyze the data and then take immediate action. So in terms of applications, the main three applications of Internet of Things is capturing data, securing the right communication and the right flow of the data and the networks, and then definitely either analyzing the data based on the historical view of this data or taking the actions. Well, the Internet of Things instruments our entire world. The cars, the clothes, everything in our world. Even from the trees to the cars, to the roads, to the washing machine, to the clothes, everything will be able to have its own sensors to communicate data on time and in a real time in order for further analysis, for immediate actions for people. As you can see here, the evolution of internet. Sorry. So the internet started with just an email and web browsing. And unfortunately, up to this moment, a lot of people, they are just using the internet for email and web browsing. And then the next phase was the e-commerce, trading over the internet, the digital internet, and then today, it's more into social media, it's more into mobility, cloud, and video. Everything is on the internet. The future, and it's already started everywhere, okay? Everything will be connected. All the things, from the car, to the clothes, to the washing machine, to the fridge, everything will be connected. We should not count only on laptops and desktops or on mobile phones to be connected. Everything will be connected, and all the data will be communicated between these things. So, the Internet of Things consists of four main elements. The people, where people in connecting with each other, the flow of information will be easier, will be accurate, and will be on time. The process which means the remodeling of the existing process in order to be more efficient, and the workflow will be easier, and the communication will be faster. It will happen through the Internet of Things. The data flow will be in real time. For example, we don't have to wait for the machine in an industry to get interrupted. All all the machines will have its own sensors, and it will send data immediately to the data center for further analysis and for immediate action. So, and the things, all the objects will be connected between each other or along with people or along with the data centers. So we will have different connections. The Internet of Things connect the unconnected. P2P is people to people, the connection between people, the connection and then between people and machine, P2M, and then machine to machine. Even objects will be able to connect with each other, and then actions and triggers will be taken further.
I don't believe we can connect them.
Well,
let's see.
Well, let's see.
Okay.
So the business opportunity, definitely with the Internet of Things and in the evolving world, we will be able to create new business models, new systems, and to penetrate new markets. Definitely, it will improve the productivity and the efficiency of people. Okay, because communication will be in real time, productivity will be better, information will reach and data will reach people on time without any delays, and at least we will have accurate and prompt information. Okay, and the most important thing is once this data is collected from the things or from the objects, and based on data analytics and business analytics softwares and applications, we will be able to have deeper insights and deeper analysis of the data and be able to take prompt and more and better, definitely, and better decisions. So this will help every business person to take better decisions and prompt decisions. Well, what is the Internet of Things in terms of value? Cisco, they have built around 21 cases based on use, from asset utilization to employees' productivity, supply chain, customer experience and customer relationship, and last it's innovation. So the value of the Internet of Things from 2013 until 2022, it will be around $13 trillion in terms of value creation, based on better utilization of assets, better, more efficient workflow, processes, and different new business models, better productivity of the employees, and better performance and better efficiency, and definitely it will improve the entire workflow from product to customer. Based on the IDC forecast 2020 view, this is a forecast done this year by IDC. We believe that there will be 212 billion things installed and around 30 billion connected things. So Gabby, it's not everything, but mostly
A lot of things.
a lot of things. So it will be, trust me, sensors can start with the trees to the, again, washing machines or the fridge or the car or the road or the traffic lights or even the parking lights to everything. Everything will be connected and everything will send data on time in order for further business analytics, for further analysis, and for immediate actions. So just imagine a forest where there are sensors inside on the trees which can send immediate data to the municipality to take actions if there is a fire or if there is anything. This is just a small example, and we will reach more examples. So the business value of the Internet of Things will be, by 2020, $8.9 trillion. It's a huge business for everyone to look at. We cannot ignore it anymore. Things will not only be connected through the laptops, desktops, servers, and mobile phones. We can get anything connected. And it already started. It started around the world. It started with few cases in Lebanon. We're going to hear about few cases. And we cannot miss this technology. We cannot miss this new trend. It's the future. Well, the top 3 business drivers for the Internet of Things are: 1, satisfying customer demands. being able to respond to their requests, to their demands, being able to personalize everything to the customer, accelerating the pace of innovation, getting new products, taking new actions, defining processes, remodeling the business in order to satisfy the customer's need, and definitely the need to automate everything. The main requirements, we need to have the right technology. So back to our example for the municipality, if the municipality does not have a data center, they cannot get the data, analyze the data, and take prompt action. So we need to have the right technology in order to be able to implement the Internet of Things. We need to have the ability to integrate technology with legacy IT. So it's very important, and we need to, the procedures within the company or within the group or within the municipality or the public sector or whatever, the procedures must be able to absorb technology. So revisiting our procedure and re-engineering our procedure will help us a lot in adopting IoT. Top 3 benefits. The benefits of the Internet of Things are definitely, we have a huge list of benefits. It's operational efficiency, better utilization of existing assets, of the supply chain, employees' productivity. So the more we use our existing assets, the more our productivity will improve, the more the efficiency we have. So just imagine an industry with non-interrupted, ongoing production machines. Customer service. So the customer experience based on the Internet of Things will be completely different, and we will see it in an example in the retail store, for example. Collaboration within company, teamwork, innovation, employees' productivity definitely will be improved. So connecting billions of new devices and operational assets, whether in logistics, in smart cities. I will go very fast through this because we will have later on some few examples. For example, in smart cities, traffic lights, parking meters, sensors everywhere. We can have it everywhere. Intelligent buildings, we can see the occupancy per room, the number of visitors, all these, and this data can be communicated easily, for example, for room service in hotels, for all this stuff, to be able to take immediate action whenever needed. Okay, utilities in terms of electricity, oil and gas, all this, and even it reach agriculture. Yeah. So an example in the healthcare, can you imagine the ability to track and trace drugs from manufacturer to patient? And the more important thing, and something much more important, is remote monitoring of patients. Just imagine having an electronic skin patches on your hand here, which will transmit and send data to your doctor, to the medical center, so they can advise you about the right medicine to take, about the right thing to do, and when they take immediate action. Can you imagine how this will help old people? Okay, so then it's doable, and they started already doing it in the States. Digital band-aid, again, it starts sending your data, start measuring your heartbeat and all other functions, okay, and transmit real-time, immediate data to the center. For example, for football players, lifestyle and fitness monitoring. We saw 2 months back T-shirts for football players that includes sensors where they can, upon wearing these T-shirts, they can transmit data about their different functions, about the heartbeat to the sports center, so they can take immediate actions about food they should have, about the number of calories, all this stuff, how much they are burning. So this is in the healthcare. In the retail, moving with the Internet of Things, it's so easy. it's like moving from CRM, where everything is personalized, where the retailer, they know your name. But now, moving to a hyper-relevant system with the Internet of Things, where your retailer knows your name, your favorite color, your best dress that fits you, your size, everything. So based on this, the retailer will be able to have for you the right stock, the right product, and be able to sell you more. It's more efficient, it will improve productivity, it will improve sales. So just another small example in the retail sector is, just imagine an enormous superstore, an enormous supermarket where you have sensors on the shelves. And these sensors will inform directly the data center whenever the shelves are empty of products. It will send an automatic instruction to refill the shelf. And the same from the warehouse. Whenever the product reaches the minimum level of stock, they send an immediate PO, a purchase order, to their preferred supplier. So this will be completely automated without any interaction from anyone. We just need to build the system, to put the sensors, to design the workflow, and everything will be automated. In the financial sector, I will be very brief here, is being able to provide everything virtually. The financial advice, mortgage advice, everything. And even, just imagine while walking into a branch with your VIP or gold or platinum Visa card, the branch manager will come and will know that you are a VIP customer by just walking in through your credit card in your pocket or in your wallet. Public sector is definitely, everyone wants to improve efficiency, reduce cost, reduce the lines and the queues. So everyone wants to get his paper, his administrative things done on the net. So everything can be done, even the delivery of the paper, the delivery of the passport. You know, in some countries today in Europe, vending machines are doing the passports. Vending machines. So, common set of requirements. We need to have an easily onboard, to be able to easily onboard any connected things, create real-time communication between the things and the data center, or the things with the people. Begin capturing data, providing access to this data, and then manage things and connect to them. And further requirements will help definitely the Internet of Things is additional data and business analytics for further immediate action, or for additional analysis on the historical data to be able to improve process. Come on. Sorry. So we're done. So in Lebanon, it's so easy. We can say that, okay, Internet of Things are so far, it's very high-end technology, and we cannot do it now, but trust me, we can do it. We have the right software. We have very good companies. We have good talents. So together we can. Thank you.
And now, Mark.
All right. Hello, everyone. My name is Mark Nader. I handle operations at a company called Data Consult. We are a technology company. I also, like Gabby said, I lead a company called Exeo, which does services and cloud. So the reason I did my gymnastics is that because I was insisting to stream, although it's not looking perfectly in landscape mode, but I wanted to stream my presentation online. So the presentation is on the cloud. And the reason for that is that I would like you to interact with me using this link. So if you have a connected device with you, a mobile phone, tablet, laptop, watch, please log in to this URL here. You can ask your questions. You can vote. If you don't want to ask your question, you can vote for the question you think requires attention from us, and then we can process those questions at the end of the presentation. All right, so thank you, Tony. Very, very interesting presentation. He presented the what. I mean, what is the Internet of Things? I was told that the audience here is into technology, so my role now is to present to you the how. Okay, so it will not be technical, but let's say it will be technology oriented. So I'm going to explain how we're doing the things that Tony described. What is the architecture? And at the end, I'm going to outline two very simple business cases which are being implemented right now in Lebanon for, and I'll keep the surprise to the end, for customers who don't usually consume technology. So the two customers at the end do not have servers, do not have UPSs, and do not know anything about technology. So to your previous speaker, I would say I'm using Google Slides and not PowerPoint, so I'm the new generation. So if we want to divide the IoT, you have everything that is related to the consumer technology. It's called consumer IoT, so the connected shirt, all the connected things that you have at home, for example, or the gadget. This is consumer IoT, and I will not cover that today. And we have what we call the industrial IoT. So I'm going to focus on the industrial IoT, and my colleague is going to dive more into it a bit later. And to try to explain how do we do to extract information out of sensors, engines, valves, mobile phones, devices. How do we take this information and then we feed them into applications and translate them into business outcome enhancing applications? I mean, how do we enhance the lives of the people working in the healthcare or in the agriculture, or enhance the lives of the citizens? And so to explain this, I'm going to guide you through an IoT data flow. All right? Is that okay? Who is not into technology? Can you raise your hand? Okay, so all right. So most of you are in technology, I suppose. All right. So in the IoT data flow, there are three big areas, okay, that we tackled when we do industrial IoT. So, and each area comes with different skills. First, we have what we call the site area. And this area is mastered by the people who do industrial automation. So they are the guys who are saying, what is this IoT? We've been doing this for the past 40 years. We used to automate things, control them. And this is, old technology. Yes, it's true. At the site, we need to capture data, and to capture data, we have the choice today. Millions and millions of sensors and devices generate data. The problem is that because they were built in the 70s, and we still use them because they are very good, thermometers or location sensors or any type of sensor, they generate analog signals. All right. So, for example, an ultrasonic sensor that measures how much oil there's in a recipient will generate a value from 0 to 10 volts, which is equivalent to the depth of the empty space inside the container. So, what we need to do, and this is the start of the revolution of IoT, we need to code this information, to take the analog information and code it into IP, into digital information, to make digital packets out of it. And although this is very important, the other important thing is to take this information out of the site. So if I'm doing a smart parking application, I need to take this packet out of the sensor, which is on the ground, and then transmit it. All right, and I have so many challenges today is that I cannot lay power cables, I cannot lay internet cables to each one of those sensors. So lots of new technologies here are playing, and this is called the RAN, the Radio Access Network. All right, so the Radio Access Network, its role is to take these packets and get them to the closest point of contact of the internet. All right. And then it is normal internet technology, so we need to transmit this over a network. And once we transmit this over the network, we need to put this data somewhere. We need to put this data somewhere to make sense of it, all right? And this, most of the time, this is done in the cloud. And what will happen, we will need to store, analyze, and take action on the data. And if we're talking about machine-to-machine types of applications, for example, I don't know, detecting a presence and then opening a door, then the flow has to go the other way around in order to command a door or a light or whatever else. All right? So this is the IoT data flow. This space here is mastered by the developers and the people in IT. This space in the middle is mastered by the network engineers, the telecom people, the mobile operators will play a very important role. And this space here is the turf of the automation and the low current people. All right. So the biggest enabler is the revolution that is happening here, all right, in the RAN. And if you remember, I was saying that, I mean, if, let's say, a smart parking solution, how do I extract this information out of every parking spot, which is in the street, or in street lighting, for example? So if we look at the technologies we have today in networking, we have, if we want to transmit information, you're not seeing it here, but a very long distance, all right? And I need a technology that consumes power. Today I have cellular or satellite, right? If I want to transmit information at a short distance, and I have the ability to put power, then I have another technology which has been around for the last 10 years, like, any guess? Wi-Fi, for example, all right? Now, if I don't have enough power and I want to transmit information to, let's say, a short distance, I also have technologies today that can work on batteries and last for years. I have Bluetooth Low Energy, Zigbee, Z-Wave, Dust, NFC. The problem is, I don't have a technology that works on a long distance with a short power consumption. And this is what is called today the low power WAN. Okay, you've probably heard on the news this story a few weeks ago. There was some debate around this. So you have three major players trying to fill this role. There's a French company called Sigfox. There is an alliance of companies called LoRa Alliance. And there are the mobile operators who are saying, hey, wireless data transmission, this is our space, all right? And they invented, or they updated their standards and invented something called narrowband IoT, NB-IoT, which means that as of probably next year, the mobile operators will be able to connect sensors as well. All right. However, studies show, okay, this is one study from Machina Research, so you'll probably see the slides online, show that most of the IoT application will be done using fixed and short-range technologies. And these are the business cases that I'm going to show you. This is a bit complicated, but it will not display correctly. But what I'm trying to say is that you will have the IoT gateway, which will be connected to a high-power, long-distance type of technology, like cellular, all right? And on the inside, this gateway will be connected to a low-power, low-energy type of application like Zigbee or Wi-Fi. So for example, if I'm in a factory or if I'm in a field or a university campus, there will be one point where I will have electricity and I will connect my gateway to the internet. And on the inside, I will distribute all my sensors to IoT nodes which don't have electricity and will feed themselves from batteries that will last 3, 4 years or 5 years or 10 years for some of them. All right? And these nodes can be, for example, for smart irrigation or for lights or parking or any type of IoT application. All right. So if you look at the way developers were doing apps, traditional apps used to work independently or used to work on a device. But today, the big change of IoT is that apps are connected to data which are generated from devices. And this is where we differentiate between data in motion and data at rest. So apps have to, today the technology is evolving and they have to treat information which is on the move. This is why we talk about data in motion. So we cannot anymore do things like we used to do before, take the data, store them, analyze them, and take decisions. No, decisions have to be made on the move. And the technology and the people who are trying to, or the companies who are trying to fill this area are the big giants like Google, Amazon, Microsoft, or others. You have also some niche players like Davra, and you have the open source world, which is also I mean, if you have the resources, it's also providing very advanced technologies. So data at rest and data in motion. So I tried to put, if you are in tech, you would understand, or you would, I mean, those logos would mean something for you. The difference between data in motion and data at rest, in data at rest, there is a lag between capturing, analyzing, and taking action. In data in motion, all of this is happening in real time and near real time, which means that all the technology needs to change. We cannot use the same vehicles. And I tried to take, for example, and compare, too bad it's not showing on the screen, to compare job postings on Indeed.com. If you compare job posting for premium, networking people, comparing to job posting for engineers who know to work on Cassandra or Spark, which are the data in motion protocols, the difference is huge. There are 6 job offers for developers who know how to develop IoT and data in motion for every developer, comparing to 1-to-1 for the rest of the developers. So this is how big it is right now. Okay. So if you see the architecture, it's pretty simple. So you have your sensors here, and depending on the type of sensor, you're going to select a different type of technology. You're going to connect to the nearest gateway. The gateway will transmit the information over the internet, and then you're going to plug in your application. So for example, here, there's a vending machine. If you have thousands of vending machines, so the IoT business case, for example, is very simple. From one place, you can know what are the popular items, you can know which vending machine needs to be refilled, etc., which enhances the operation, makes you make more money and save on your operation costs. So, I don't know if you're able to see this. Too bad. All right. So, now, sometimes, so we've seen that most of the computing and most of the intelligence is driven from the cloud, because there's no way you're going to keep up with all the technology and the innovation which is being done. But sometimes these decisions have to be taken locally. So for example, in Lebanon, I don't have the ability to stream everything on the cloud. So if I have a connected bus which is filming everything that is going on and has sensors on the speed, on the consumption of gas, etc., I don't want to send all the video feeds to the cloud. However, I would be interested to store the feeds if something happens or if an incident has been detected. So that's the role, that's what we call fog computing. It's the role of the gateway, which is sitting inside the bus, to take those decisions. So when we take the decisions closer to the source of information, this is what they call fog computing. And if we want decreased latency, meaning I don't want the information to get to the gateway and be processed, I want it to be processed immediately on the spot, this is called mist computing. So mist, fog, cloud, and all the applications will include at least cloud, and then depending on the applications, we can go to the fog or to the mist. So at the end of the day, IoT is about information technology and operation technology coming together to achieve a business outcome. This is what it's all about. And before I leave, I wanted to show you 2 business cases, mainly driven from smart agriculture. So these are most of the cases that we're seeing right now in Lebanon. So farmers or cooperatives who want to use technology to enhance their performance or enhance the quality of their products. So in the farming world, what applies is the network topology, where we have one point connecting to the outside and then a meshed network on the inside operating without batteries, which works very well in the farming industry. So I want to put sensors in the field, but I don't want to connect those sensors physically. So put batteries and let them work together, and then at one point I connect it to the cloud. So this is the first customer. He's an it's a cooperative of olive oils producers in the north. All right? So these guys have nothing in tech, not even a data center. And they told us we have a problem. We are, putting our oil together and stocking it in stainless steel containers, but the variation of temperature is affecting the quality of the product. And there's nobody there because the business is not big enough to justify, a structure or people around it. So please try to do something where when you detect variations, you put the generator on and put the air conditioning and then restabilize the temperature. And we want to monitor everything to compare and make sure that the quality is maintained. So technically, it's a very easy type of setup where, of course, you need an IoT gateway on site. So small intelligence, the fog that I was talking about, connected to a couple of thermometers, industrial grade thermometers, for example. In this case, we use the thermometers from Siemens. And this is for the input. So they read actually the temperature. So it's scaled from 0 to 10, and the thermometer can go, for example, from -10 to +50. And depending on the value, we know the temperature. And it's also connected to a generator using a digital output. So what happens, the gateway gets this information, puts it into packet, transmits it, you're not seeing it here, over a 4G network on to the cloud, where we have our own application built on top of an open source platform. So what we do, all right, okay. And it also has a GPS. So first, you can visualize the location of the device, then click on it, and then, like any type of application you use today, be able to map the temperature, see some visualization, generate some reports, historical reports, compare data, etc., manipulate the data. And also the application would trigger, based on the thresholds that you have put, starting the generator or turning off the generator. And if the farmer has a normal phone and not a smartphone, it can communicate using SMSs here, saying, for example, I just put on the generator because the temperature reached 23 degrees. Or even if the farmer is a bit more connected, it can send him a tweet. So all this technology is coming together from industrial automation, mobile, IT, to achieve a business outcome. And the outcome is we want to stabilize the temperature because we want a better quality olive oil. All right? Second example, a farmer in the south. All right, and he came and told us, I have a problem where I have a big plot of land, but with different exposures to the sun. And as farming in Lebanon is not very scientific, and not many farmers do their work correctly. They've been doing it like their fathers and grandfathers used to do it. So, which is not necessarily the best way today. So he said, okay. He already invested in some technology. He invested in sensors, and he is relying on his farmer to go and put a reader on the sensor, verify how much the land is irrigated or is moist, and based on that, the farmer would direct the irrigation. So he said, okay, I want to automate that, and I want to rely on anyone doing it for me. So what do you need? You need earth resistance sensor. It's an hygrometry sensor which measures how much the earth needs water. And you plug it 50 centimeter into the soil, and it generates a 0 to 10 volt value. You put this into an IoT node, which has a battery that lasts 10 years. And you make a network of those with a GPS antenna. And so you know where each one is located. All right? And you have the same trick. You put it through an IoT gateway connected in one place that gathers all this information, plugs it on the internet, puts it into an application, and then it becomes like any application that you develop. Once the value reaches a certain threshold, you can, using the output of the node, command a valve, small device, which will open the water on a certain circuit and start to irrigate. Now, once the sensor detects that the threshold reached the level of irrigation that you want, it will not command it here. It will send this information here. The application will recommand the valve and shut it. And this on the different circuits, water circuits that he has. So if you look at the result, finished almost. So if you look at the results, you have a map with the different sensors, different locations. This is, current technologies, Google Maps, very responsive designs, etc. Things that any good contemporary developer can do. And then you have widgets with values. I mean, very nice, looking on a phone and looking on a tablet, and manual override commands for the circuits or automated commands based on the application. And so the farmer can really focus on what's important, taking care of his land, instead of really, just opening the nabrish and dropping water inside, wasting water. So we haven't measured the results yet, but it appears that it's responding very well. And probably in a few months, we'll be able to know if the productivity or the efficiency of the land is producing in a more efficient way. That's it. I hope you enjoyed it. If you have any questions, you can log them here, and we can talk about them a bit later.
You already have 2 questions from the audience.
All right.
Actually, I will.
You want to do them now or at the end?
Maybe you can do them later, because those are general questions.
All right.
Okay.
Okay. It's okay. Go ahead. You can ask questions for all the sessions so that we can keep the session, the questions of. No, put them here. Send it here, and at the end we'll answer them.
At the end, we are going to do Q&A for everybody. Okay.
Tafadhal.
Muhannad.
Good afternoon, everyone. I am Mohannad Salam, founder of Rubik's Smart Solutions. And answering Mr. Gabi, we do, currently we're focusing on IoT solutions, industrial IoT solutions. And Rubik's has been always looking for innovative technology solutions, helping businesses improve efficiency. Our title today is Smart Food Safety Management. It's a very attracting title. And may I start by asking who's in the F&B industry here in the audience? Yourself. Okay, so this is very much into the F&B industry, and for you, I'd say, and for everyone, I'd say that today I'm gonna show you how Internet of Things was invented to help solve real-life problems, and sometimes life-threatening problems like food safety. Life-threatening, if we look into. Okay, we'll start again. So we're talking a lot about life-threatening problem which IoT is trying to solve. And why is it life-threatening? If we look into that report by WHO, which is the World Health Organization, in 2015, they are saying that foodborne diseases are causing 1 in 10 people to fall ill. That's a massive number. 1/10 of population yearly is getting ill because of foodborne diseases. Out of them, there are 420,000 deaths. And among those deaths, there's 1/3 of that number children, which didn't develop their immune system yet. That's why we're saying that this is a very life-threatening issue, which is foodborne disease related to food safety. And at the end, they mentioned some very important title or sentence saying foodborne diseases are preventable. And everyone has a role to play. And us, Rubik's, we chose a role. We chose to develop some innovative solutions using Internet of Things to help try to minimize that number the possible. Another study was done in Europe, which is correlating between temperature rising and reported cases about foodborne illnesses. So if we look into those two graphs, or those two rising graphs, we see that whenever temperature is rising, we're hitting, sorry, the titles are not showing, we're hitting more and more reported cases of foodborne illnesses. So temperature is the main concern for food safety. So what are F&B companies doing right away? for food safety. They are doing their homework. They are using what they have in hand currently to monitor and try to keep temperature as much as possible in the acceptable range. But what they have in hand currently are either manual log sheets, or at best cases they have data loggers that they plug in the computer at the end of the day and they capture all the data. And in both cases, we lack the automation. We lack what Mr. Mark was saying, the live time interaction with the data. So that data is gathered on the desk of the food safety manager, and he will see it maybe the next day. So he will see that yesterday the temperature hit. He's not seeing it right now. Same thing with the data logger. So in both cases, we're having lack, delay, and we're having manual interaction, which is prone to errors. And that's why our minister, Abu Fawr, is unhappy, as we can see in that picture. We lack a lot of stuff. And I'd like to focus on one of those, which is lack of analysis and BI, which is the core benefit of Internet of Things. Internet of Things is all about collecting the big data and trying to run analysis about it and trying to benefit from that data to predict the future so we don't fall in the problem again and again and again. How can we do that? This is very important for the Internet of Things. So our solution, titled Smart Food Safety Management using Internet of Things, as you can see, the components of the solution, we have the hardware part, which is resembled in sensors and gateways, and those sensors are in various types. They are mostly wireless sensors, so you have the plug and play and easy installation of the system. Those sensors can be temperature, humidity, light, soil moisture, as my friend said. We have pressure. It depends on the business situation. We'll find the sensors. There are tons of sensors. And those sensors are communicating and sending the data to, in our case, Microsoft Azure. We chose to use the cloud of Microsoft Azure, where Microsoft have developed serious and extraordinary services under a title of IoT Hub, where they allow every developer, any developer, to build on top of those services, and we'll have the benefits of scalability, of reliability, of security, all in that cloud here. And the end result would be a mobile application or a web interface that you can see on the go, wherever you are. So your facility is in your hand, wherever you are, and you get alerted if anything goes wrong at any time of the day. So no need to go and check the papers, what happened yesterday. If I'm sleeping at 1 a.m. and something happened, I will get notified. I'll directly call my team and tell them, check what's happening there. Unfortunately, it's not clear. So those are other examples of data analysis where we can see the temperature trend per day of the week. So how is it on Mondays? How is it on Tuesdays? How is it on Wednesdays? Weekends or weekdays? Another example, how is it afternoon? How is it at rush hours? How is it? So you are able to gather all those temperature data in a very friendly reports or dashboards where you start as a business owner or food safety manager, develop your own business intelligence about that. How can we improve? Well, the temperature seems to be very high at rush hour, where everyone leave work to come at our restaurant to eat, or I don't know. So maybe at that time we should implement some more temperature control or add more temperature units, AC units. So that's the job of you when you have all that data with you. The benefits of this solution or the Internet of Things in general, as we can see, the first benefit is improving regulatory compliance. And this is tackling our problem, which is food safety and lowering the foodborne diseases. So we're able now to tightly monitor our temperature and keep track of that temperature through all the year, 24/7. I don't have any gap. Whenever something happens, I'll get alerted. Everyone in the team will get alerted. Improve operational efficiency. So we talked about that example where I'm sleeping at 1 a.m. Usually, we have our fridges and supermarkets, and we have our staff running around all the time. So if the temperature runs a bit, maybe they will get notified. But if it happened at 1 a.m., nobody will get notified. And we will only get notified the other day when we wake up in the morning and go to our facility to find out that the food is spoiled. The temperature was off for 6 hours and everything is spoiled. And that's a lot of operational deficiency where we need now to shut down the store, nobody enters, it's bad reputation for us, and we need to throw all the inventory or the food and to recover. And reduce business costs. Let's talk about this regarding the predictive maintenance. Another example here. If we have a freezer that's usually minus 20 degrees, that's the normal temperature, minus 20 to minus 18, that's the freezer. But it's allowed for the freezer to fluctuate between minus 20 and minus 16, minus 14, depending on the operations, on the daily operation. But what if that freezer is not coming back to minus 20? Nobody will notice because it's not alerting us. It's still in the normal operational range. There's nothing wrong with the temperature. Food will not get affected. But our machine, because there's a machine learning running there, and because we are using IoT, predictive maintenance methodology, our machine will tell us in smart alert that, look out, this fridge or freezer has not get back to minus 20 since 3 days. There might be something wrong there. I'll call my maintenance team to tell them, please go check fridge number 13. Something is wrong there. And they go there and find that there might be some gas leak, or maybe the compressor is about to get bad or spoiled. And that's very important, actually, because we're hitting the problem before it happens. We're able to predict that something will go wrong. And we're able to solve it. And this is reducing business costs because we are able to save our assets, not only our inventory.
And this is actually implemented here?
Yes. Nice. We'll come to that. Okay, so those are the main benefits of the Internet of Things. So this is a slide talking about the benefits or the edge of Rubix, my company. We are solution innovators using Internet of Things technologies, and we have regional experience implementations. We are Microsoft partners. Our hardware are Zigbee certified. We have 2 years warranty on all hardware, and they are all made in Italy. And all our solution is built around the Internet of Things technology from Microsoft, Azure Cloud or Azure IoT Cloud. And not only that, we love Internet of Things. We really love that. Every aspect of this technology, we love it. Is that for me? Okay. Thank you. So that's Rubix. Now, luckily, we implemented that in Lebanon with our first client, who is Balqis. If anybody does not know Balqis or did not taste Balqis yet, My advice is after this session, run to the first supermarket, grab the bottle of Balkis orange juice specially, and take it all. Don't share it, just take it all. This is amazing. It's the most amazing thing in it is fresh, 100% fresh, and it's 100% Lebanese juice. And they are, if we can say, early adopters of IoT. They took that whole solution we're talking about and implemented in their facility. So we are monitoring their temperatures, their humidity, and we are monitoring their warnings and alerts from the PLC system. So if anything happens at his factory, he will get notified on the spot. And luckily, while we were in this project implementing it, they have a rule there that don't drink water, drink juice. So I had to drink juice on 1 year in that project. So why cloud? This is a question that we might answer at the end. Some clients actually still don't believe in cloud. When we tackle them or when we explain our Internet of Things solution to them, they said, okay, I'm fine, but we have our own data center. We need to use our own servers. We don't want to send our data to the cloud. They believe that this would be more cost efficient for them if they use their own data center. We don't need to prove it because it's already proven, and there are studies saying that when you use cloud computing versus on-premise computing, you are saving 77% less. And it's not only about cost, it's about the platform. Whatever the data center that you have, you are not able to match a cloud professional data center like Microsoft or Google or Amazon or whatever. Those are done to be masters in what they are doing. And last for me is why I'm using Microsoft Azure. Well, if you Google that question, why Azure, you'll find a lot of answers and you'll find a lot of debates. This is better than that, Google is better, Amazon is better. I'm not going into all that detail. I'll just look into that slide, which is telling me that more than 85% of Fortune 500 companies are using Microsoft Cloud. And if those people know what they are doing, they have their technical teams and they have their financial teams, and they base their decision on very careful study. So I'll base my decision on their decision, and I'll choose Microsoft Azure as well. Let's stop foodborne diseases or illnesses, and that's our message, and thank you.
Well, thank you very much, Muhannad. I will not ask a lot of questions. We will take the questions from the ones that we had from the audience.
An IoT over a BMS system, which is available for many years, and it can make everything you have talked about right now. I see a disadvantage is to share all my data on the cloud and to not be able to control it with the IoT. What do you have to say about this? I'm just.
So I started the presentation by saying that automation, people from automation will tell you that it's been around for years and decades, and they've been doing it very well. And IoT does not replace BMS, actually. IoT uses the power of BMS. So BMS will be able to manage your facility. But for example, if you want at the same time to manage the facility and to detect the mobile phones which are entering and exiting your facility, how would you do that in BMS? In IoT, it would take a developer a few minutes to do that. Now, if you want to push some data from the facility onto a web portal or onto a mobile phone using BMS, it's very complicated and very costly. When you interface your BMS with an Internet of Things system, it becomes much easier. When you are on the move, when you want to link your BMS to multiple sites, to your cars, this is where IoT comes into play. So again, it's operation technology like BMS with the power of information technology, the cloud, mobility, and this is IoT. This is the two, coming together. Yes, of course, the objective of the IoT is to achieve a business outcome, either to reduce cost, to sell more. Here in the case of food safety, is to avoid, losing your your inventory. So it's all about the cost.
It's becoming efficient, and as a BMS system, as a controller, as a PLC, as
it doesn't replace
the wireless. It doesn't replace. It communicates with it. A BMS or a PLC can be integrated in an IoT system.
Yes, of course. This is PLCs are there and they connect with IoT. IoT is not there to replace it. It's just a word to say. The Internet of Things. So the BMS becomes connected to the Internet. The BMS sends information to a cloud so that you can do analytics on it. How many
you have more features.
Yeah, exactly. So. To be able to detect when things are happening and all of the things that you talked about. I don't know if you want to add something.
BMS is not implemented in all facilities. So if you have an existing facility and you'd like to implement a BMS system in it, that will be highly costly. Where Internet of Things, as you saw, it's a plug and play thing. So retrofitting is definitely Internet of Things. You cannot do a BMS. But if there is a facility that has BMS, as my colleague said, then yes, benefit from the cloud, benefit from the new features. Definitely, an old technology compared to a new technology, there are a lot of new features developed there. So let the BMS benefit from those features. And talking about the cloud and security and that my data now is in the cloud so everyone can see it. It's not true. The cloud is your cloud. It's called cloud so that you can access it on the go wherever you are. You can benefit from that. It's like your Gmail. Nobody can see your Gmail. It's you. But if you don't have your Gmail, you have to carry a laptop all the time with you to read your emails, right? That's the same thing for that.
Thank you.
So just to add one important thing about the cloud, with the IT and the technology that we're reaching, no one can live anymore without the cloud. So it's very crucial, it's very important, and we can never say that, okay, we're gonna be offline, we're gonna continue. What about mobility? What about sharing data? What about collaboration? You cannot do anything without the cloud. So it's like moving the old cameras from ACFA cameras, okay, to the new digital, and the IT people who will still try to avoid or to block the cloud, they will be out. So it's very important that, okay, we adapt our technologies to the cloud and to the new trends.
Okay, yes, please. Go ahead.
When I wrote my question, everybody was anonymous. They checked the anonymous box, only one. So you can see that everybody wants privacy. And like he said now about the privacy, I had also this question. When you talked about the Band-Aid, like how does security work? And it can be hackable. And when you control your home, and they can just come. And if I'm talking, how the security works.
Definitely, security is one of the main challenges in everything, from Internet of Things to the normal internet to emails to everything. So there are many security options, many security softwares to protect. So today it's a big challenge, and I appreciate it. So but definitely there are many solutions for this. Leaking data about the health or about the financial data, it's always something, a big threat for everyone, for citizens, to consumer, to corporations. But definitely there are many security solutions to avoid this. So it's a big challenge, and I believe that it's like the virus for any laptop. It can hit your laptop anytime, but there are definitely many solutions to avoid it.
Yeah, but for the privacy, like when you said it's in the cloud, it can't just be in the cloud. It's in somewhere cache. Like they go in the cache, and when you doubt that somebody did something wrong, you go back in his history, right? So there is still the people behind all that controlling the information, even if they don't know everything. But if they want to see the man what he's doing in a high position, they just go and search.
You're saying something that makes lots of sense, and which is very a big problem today. Actually, we have always protected our information systems by using a fortress approach. Okay, for years and years and years, and since the internet existed, we always try to do a fortress approach, meaning I have my network, I have my information systems, my data center, and I build around it a fortress. I put firewalls, and then IPSs, IDSs, all these next generation firewalls. All the security was to protect from the perimeter. And now with IoT, I mean, this fortress has become like a wall, a Swiss cheese wall with lots of holes, because suddenly you have a thermostat inside your application, inside your center, which is connected to a service on the internet. And it's bypassing all the security. So yes, there is a big problem, and if you read around about it on the internet, you'll see that it's the end of the fortress approach. So now companies are figuring out a different way. They are saying we need to consider that we are vulnerable and we are always connected to the internet. And if you want to test this, just put your laptop at home, keep it open for a few days and see how it will be infected. So we have to consider that even in the enterprise, we're connected to the internet, and the security will not be about connecting our perimeter, because it's useless, because on the inside, things are connected to the outside. Security would be about connecting or securing the relationship between each user and its application, which means that the only way today is ciphering. So 50% of the internet today, thanks to Facebook and Google, is secured and ciphered using SSL, if you notice on the website. And in a few years, we will reach 100%. So it's about securing the transaction. And when you secure each transaction, then you can put all your enterprise on the internet, because you are secure even if there are caches in the middle. It's not
to secure the transaction.
It's of course
secure the device.
Of course.
Itself being infected. You have so many malwares today.
But let me tell you one thing. Cloud is actually more secure than off-premise. And take the example of Stuxnet and the problem with the Iranian nuclear program. So they were disconnected from the internet, but they were infected, and it's an Internet of Things infection. They were infected because, in any information system, you are as secure as your weakest link. So the infection came from a Windows PC. They used a zero-day malware in a Windows PC to get access to the PC. And on the PC were the management system of a SCADA. It's a bit more sophisticated. It's the BMS of the industrial world. So, and this automation system was controlling the PLCs, okay? And these PLCs were actually commanding the acceleration engines, and they managed to disrupt their program by just entering a malware on the Windows PC without being connected. So today, cloud is more secure than on-premise, because you will never have the budget of Microsoft, Amazon, Google, the budget that they spend on security.
So
I'll just try to add some simple answering for this security issue. you're talking about hacking, or the people behind the cloud, are they able to see what we have on the cloud? The developers or or governments? Governments, yes, definitely. If they have the will, they can do anything they want. They can approach you at your home if they want. So
But
let's forget about the governments. That's not our case here. Let's talk about developers behind the scene. Or let's talk about the easy question, anybody can see me or not. The answer is, as Mr. Gabi is saying, your device. Let's start with your device. If you choose your device based on price sensitivity, you're mostly falling into the security gap. Nowadays, you can find a lot of sensors on the internet. And a lot of sensors from very tough companies. So a sensor from on the internet will be $10, let's say a temperature sensor. And you'll find that same sensor for $100 from Siemens. So if you choose to go with Siemens, you're securing yourself. If you choose to go to that $10 sensor, I don't know what will happen with you in the future. And same thing with the cloud. There are cloud subscriptions that are very cheap, and there are some cloud subscriptions like Azure or Google or whatever that are high enough. And price-sensitive people will always choose the cheaper thing. And then will blame the Internet of Things because they got hacked. The problem is not in the Internet of Things. If you put your data in a secured cloud, maybe you're paying more, but you're paying for the security. So the first or simple advice for anyone is, when you want to go into the Internet of Things, be it a smart home or a smart facility or whatever it is, choose your devices carefully.
But it's not only the technology, yani, it's the company that built a confiance. Yani. It's not, why they don't do that? Yani.
I didn't get your question.
It's more about the company owner, like the customer having confidence in the company owner. It's not about technology. Trust.
Yeah, trust in Microsoft.
Yeah.
So if Microsoft fails you, then Microsoft...
How do you show the trust? How do you gain our trust?
When you look into those, when I showed that 85% of Fortune... Yeah, exactly. There are some measures that you should look at before choosing.
But you are right. We have no standards in security yet. Okay, great. Let's have another question.
I have a basic concern, I believe, since you're pushing for the cloud, and specifically in Lebanon. Where do we see Lebanon with IoT concept and cloud concept? However, we're still struggling from the internet connectivity. You know well the last incident of Ojero, specifically in North, which we went out of internet for a couple of days.
You're very right in what you're saying, and we faced that when we developed our system for Balqis. We find that where he is, there's no internet connectivity. There's no Ojero, there's no DSL, there's nothing there. And 3G signal is very low there, and highly cost. But what can we do? So yes,
so
your
it's a
concern is a very big concern, that Internet of Things needs internet. And the internet infrastructure is still poor, and in some areas it's not there in Lebanon.
Maybe Mark, you can tell us about what Ojero is trying to do in this area.
So the Internet of Things, you're right, depends on the internet. But that's the bad news. The good news is that in those applications that we have seen, it's mainly telemetry, so which means that we consume very little amount of bandwidth. All right, I'm going to send the temperature, small packet, 5 bytes, 10 bytes, you know. So that's the good news. Now, in my presentation in the beginning, I was saying that there's a gap for long-range transmission with, short power. This gap today is trying to be filled by three companies, three groups of companies. There's a French company more than 5 years ago. They invented a protocol. The company is called Sigfox. And what they're saying, in your case, all right, the customer needs to send small amounts of packets on, a distance of 10 kilometers, for example, just to reach the closest city and then transmit it over normal mediums. So they said, okay, we're going to invent a protocol. They invented a company called Sigfox. They invented a protocol which works on the frequency which is close to the TV frequency, the UHF frequency, which means that it can penetrate indoor and it can, transmit on long ranges. And the problem is because it's a low frequency and very narrow band for the radio people here, so very narrow band, so you cannot pack lots of information for it. So it's ideal for IoT. And because it's small and you don't pack lots of information, it's not consuming lots of bandwidth. So these guys came in. The problem is that it's a French company. And what they're saying, they're going to operators and they're saying, okay, we will build the network for you. You buy the equipment. But the actual data will reside in our data centers in France. So this model maybe does not work with everyone. So there's another alliance which has been created called the LoRa Alliance. And lots of companies in this alliance from different areas, Chinese, European, Americans. And they said, okay, there is a need, like you said. There's a need for this. We need to transmit information. And they created the equivalent, and they called it LoRa WAN. And it's the equivalent, but it has a bit more flexibility. They say, okay, the operator chooses where the data will reside. All right. And as I told you in my presentation, the operators also saw this. They said, okay, wait a minute, somebody is stealing away. You were saying 30 billion devices connected wirelessly. No, we want that market. And they created a standard called NB-IoT. NB-IoT will use a small chunk of 4G, and it will dedicate it for telemetry and IoT, which means that because it's a small chunk, it's narrow band, and it's small amounts of data, it will transmit further than IoT, and it will handle many more devices. So if today a base station in 4G can handle maybe 500 phones, an IoT, this same base station will be able to handle 100,000 devices. Okay, so the problem is solved. Now, in Lebanon, one of the actually positive initiatives that is encouraging for IoT, Ogero, the Ministry of Telecommunications, have decided to invest in one of those technologies. Mm-hmm. They chose the LoRa technology, LoRa WAN. They say, of course, they can talk about it, but they say that they chose LoRa WAN because it's open, so it has it's not one company, and because the data actually can reside in LoRa. And this might be a problem for companies, for example, which are not comfortable to have their data outside. So,
sure.
So a LoRa WAN RFI has been issued last month. The submissions were last week, and I think they are expecting everything goes well,
any visibility,
bidding and finished by January.
January, all right.
So which means that if it goes well, and the winning company will probably take about 6 months to deploy, and LoRa is just a radio which is as big that will sit on top of the building, will transmit information. These radios are connected to a backbone, and there's a server in the middle reading and pushing information to the sensor which are connected to the radio.
Interesting.
So it solves the problem, not the internet, because this is more robust. It's like TV signals.
Thank you.
Okay, we have a question.
So in their RFI, they want to cover all of Lebanon, outdoor. No, actually in the RFI, they're saying, give us your design, and we want to cover all of Lebanon. In their model, model is like a model also done in South Korea. It's very similar. In South Korea, SK Telecom, which is one of the most advanced telecom operators in the world, incumbent in the world, as you know, in South Korea. So SK, in their model, they will do only the operation, and they will partner with third-party application providers, like Rubix, for example, And they will tell them, okay, you bring the sensor, you do the application, and we'll provide you connectivity. We'll just transport the data. Right? That's enough. Yeah. I mean, for those of us involved in IoT, this is great news because it solves the connectivity problem. Because I don't know about you, but when we work on, and we've worked also on similar projects, we have two headaches because the technology is very easy. The headache of selecting the right sensor. We haven't talked about this in detail because some sensors need power. You know, when we talk about temperature sensor, I mean, you can power them easily by battery. But if you talk about, for example, ultrasonic sensors, they need power, and you cannot get power everywhere. So, and they also need to transmit information. So, if we can solve this transmission problem by a national IoT network, it will help us accelerate a lot the deployment of IoT applications.
Can we know more details about the hardware and the softwares used in IoT, like programming languages or some recommendation for a new?
I put them in my slides. If you, it will be shared, I think, by the Lebanon opportunities. But what you need to know is that in the IT part, you have lots of things, but lots of technologies today are associated for data in motion, and between them, this is one thing I've put. Very impressive. It's a protocol or a framework called Kafka. If you know it, Kafka. Apache. It's a framework developed by Apache. You know Apache, the web server, who developed Hadoop and Spark. Okay, they developed now Kafka. Kafka is also a way to treat data in motion, which is and transiting. And okay, Python is used a lot at the fog part. I don't know if you're using Python on the IoT gateways. Most of the IoT gateways are based on Linux. Okay, and the programming language is scripting language is Python, PHP, and all of these.
You are not using HTML5?
In HTML5 in the UX part, yeah. Yes, of course. Yes. And you also Node.js, all of these. Node-RED. I don't know, maybe it's more your area.
There's no one language. Developers have all hands to put in Internet of Things solutions, but depends on which layer you want to work on. If you are looking to work on the gateway, then you have the PHP or Python or Linux. And if you want to go into the user interface, you have all the facilities. So it depends on where. If you want to go into the sensor and how the sensor is communicating, so maybe you need to focus on the technology. It's Zigbee, it's Z-Wave, it's Bluetooth, and see how you need to communicate. What's the APIs and so it depends on which layer you're focusing.
One more question. What we could find in 5G technologies?
So 5G,
what we can...
So now, as I told, NB-IoT is part of 4G Advanced Pro. So the 3GPP standard, 3GPP, which is the organization that handles the standards of 3G and 4G, have created version 13 of 3GPP. They call it LTE Advanced Pro, if you want to look it up. So the LTE Advanced Pro will incorporate NB-IoT. And this is, of course, it will be part of 5G, because one of the main drivers of 5G is the Internet of Things and low latency, especially for the connected cars and the connected mobile.
Okay. So don't you think that implementing such a network for IoT in Lebanon will definitely need an increase in international capacity or international bandwidth or even local bandwidth?
Yes, of course. I mean, they are small packets, but if you achieve scale, and
of course.
For example, if you have 1 million connected ساعة كهرباء وساعة مي I don't know how many
sensors على الطريق يعيشوا في السيارات وين
imagine each one of them sending one packet per hour.
and using the 5G networks. All of them using the 5G network.
That's a different topic, right?
Yes, go ahead. Just have the microphone and we are recording.
About how do you do your work يعني you cooperate with Ogero أو كيف بيصير يعني how do you do your work with the internet of things يعني you cooperate with Ogero who gives you the Wi-Fi وكل شيء
You don't need to cooperate with anyone. You need to cooperate with your client first of all to tackle a solution, to tackle a problem and find a solution for it. And then you find your way in getting internet. So if there's DSL or there's any internet available, we'll be using it. If not, we'll try to find a way, 3G or whatever. So in our case, as said, we are using 3G in this situation. Fortunately enough, there is enough signal to transmit the message.
yeah but I mean يعني who gives you the 3G don't you do an agreement with the
No. You can just get
Dodge
a modem
Alpha.
in place. يعني,
Just
you
a
don't
connection.
need to go into this yet. We're not talking about a smart city project where we need to tackle the government to find a solution or a price. We're talking about simple small projects that can be handled with a SIM card.
And the data transmission is very limited. You're not sending a huge package.
But even though it's not a huge, because of the frequency, it will consume a lot. Okay, so if you have 100 fridges, each of them is sending every 15 minutes. If you do the math, you'll find that at the end of the day, you're consuming a lot of data.
But even Alpha and Touch today, before NB-IoT, before LoRa, Alpha and Touch, both of them have a machine-to-machine subscription. So it's a special SIM that you buy for machines. So telemetry for this kind of usage, for low usage, and it's a different pricing than the normal internet. So this is what we use, but it's available almost off the shelf. You can go, you can buy the cards.
thank you
Small question. Sigfox or other company already implemented in Lebanon, or other than the project of Ogero and LoRa?
Sigfox implemented in 24 countries. This is what they say on their website right now. LoRa, which is the equivalent technology, I don't know how many operators, but you have lots of references adding up. So, for example, in France, they have now they are rolling out 9,000 base stations. In Switzerland, they made 25,000 indoor base stations.
LoRa.
In Dubai, I think Dubai they have both. So they are competing right now for market share. So
But in Lebanon, there is no one
in Lebanon,
available
no,
right now.
They decided on the technology. They decided to rule out Sigfox and to work on LoRa.
But there is no opportunity for other company also to implement their infrastructure and their system?
Well, actually, LoRa is not. It's an alliance. So
Okay.
they did an RFI. 20 companies actually took the RFI because my company is one of the bidders, so I can tell you information. And there were 7 bidders.
Okay.
So us, Nokia, other
Okay,
Chinese
but
companies, French companies.
okay.
So many companies bid it because LoRa is a protocol.
But this was adopted by Ogero, the LoRa.
Not yet.
Not yet.
They did an RFI, request for information.
Okay. But can private company or private sector have also another network and another?
LoRa has been designed for that in mind, so that if you have a campus or a plant, you put your LoRa station and you serve it. It has this flexibility.
Okay.
However, I think because we try to import it, and I know some universities try to do it. The regulators, so Ministry of Telecom today, are not letting you bring in LoRa. They are telling you now, if you want to use LoRa for your own internal use, يعني كيف التليفون and the wireless will do it,
Okay.
you are allowed to do it. But if you want to use it to provide a service for customers, you don't have, you're not
The
allowed
right
to do it
plan.
because there is a monopoly on Ogero.
Okay. Okay, okay, I see. Was the question. Okay, okay. Thank you.
We are used that the IT companies in Lebanon do lots of subcontracting for projects outside of Lebanon. Is there a way that the IoT could be subcontracted for other countries, or you should be on sites to do the projects?
Actually, the on-site is only for the hardware implementation. Everything can be done remotely. So it's easily subcontracted. If you have channel partners that can get you some projects from region, like we are doing, you're able to do the technical training, and someone will do the installation there, and you can do the remote software development and all that stuff, and support from here. So.
It's not allowed to bring in the equipment for the LoRa and the Sigfox. So how was it implemented?
3G. It's 3G, and in my case, we also use the 3G.
Okay.
So I gave you the example where we aggregate everything using a protocol. I don't know what you use, but we use a protocol like Zigbee called Dust 802.15.4, which is able to do meshes at low power. And then at the aggregation point, which goes to the internet, we use 3G.
Okay. Thank you.
Okay. Thank you.